pleased to welcome you to this Green Chemistry webinar as part of our Safer Chemistry Challenge Program Spring Webinar Series. My name is Cindy McComas, and I'm located at the University of Minnesota, in addition to being working as a co-project manager with the National Pollution Prevention Roundtable's Safer Chemistry Challenge Program. This webinar series is intended to provide you with information and resources that will help you advance your efforts towards safer chemistry as part of your sustainable business program. The webinars in this series help advance the goal of our Safer Chemistry Challenge program. That is to motivate, challenge, assist, and reward companies as you explore safer alternatives to chemicals that are of concern to human health and the environment. Next slide, please. This challenge program is a unique partnership between industry, states, and nonprofits. It can also accelerate opportunities for you to capture emerging markets for products with safer chemistries. And finally, it results in a cleaner environment while providing value to your company's bottom line. You have tuned in for the webinar Cradle to Cradle Certified Product Program, a holistic continuous improvement framework. This webinar will discuss the Cradle to Cradle Certified Products Program, a multi-attribute continuous improvement methodology that provides a path to manufacturing healthy and sustainable products for our world. The program guides continual improvement toward products that meet the following criteria. They're made with materials that are safe for humans and the environment, designed so that all ingredients can be reused safely by nature or industry, assembled and manufactured with renewable, non-polluting energy, made in ways that protect and enrich water supplies, and that advance social and environmental justice. So before we begin, we have just a few logistics to cover. During the webinar, all attendees will be on mute, so if you have questions, please submit them through the Submit Question option in the toolbar that GoToWebinar provides, and questions will be answered at the end of the webinar. We would very much like to hear from you on how this webinar helps meet your company's program needs to move towards safer chemistry. Again, at the end of the webinar, you'll receive a survey, so please be sure to provide us with some feedback on that. Now it's time to introduce our webinar speaker for today on the Cradle to Cradle Certified Product Program. Dr. Susan Klosterhaus is an environmental scientist with more than 15 years of experience studying the fate and toxicity of chemical contaminants in the environment. Currently, as senior scientist for the Cradle to Cradle Products Innovation Institute, Susan is the lead manager of the Cradle to Cradle Certified Products Program and oversees development of its certified product standard. She also serves as the chair of the Institute's Certification Standards Board. Prior to joining the Institute, Susan was the lead organic contaminant chemist at the San Francisco Estuary Institute, where she led research on contaminants of emerging concern in aquatic environment, as well as the identification and analysis of flame retardant chemicals used in consumer products. Before moving to the Bay Area, she earned her degrees and was a research scientist in laboratories at the University of Maryland and the University of South Carolina. So now let's begin the webinar with Dr. Susan Klosterhaus, Senior Scientist, Cradle to Cradle Innovation Institute. Susan?
Okay, thank you. Let's see, I'm transferring control here. Okay, thanks. It's a pleasure to be here. I'm very grateful for the opportunity to present to you all today. So I'm going to be providing an overview of the Cradle to Cradle Certified Products Program and essentially what it means to be Cradle to Cradle certified. But if you take anything away from my presentation today, I hope it's this. And that is that Cradle to Cradle is not just a certification program. We think of it as a global quality standard that is also a sustainability platform. So it's not similar to just being a pass-fail, one-time certification and you're done eco-label. As part of our program, certification holders must demonstrate progress at each recertification on improving their product in order to stay in the program. So in this sense, it's truly a holistic, continuous improvement framework. So first, it's important to understand the fundamentals of cradle-to-cradle design. So cradle-to-cradle is a process, really, or a platform for creating products that meet each of the following ideals. Foremost, using only those materials and chemicals that are safe for humans and the environment. And then coupled with that, that these materials are designed to facilitate the reuse and recovery of those materials through recycling or composting. Also, we look at manufacturing processes, so maximizing the use of renewable energy during the manufacturing of that product, respecting the local watershed, in other words, not impacting local water quality, and making sure that the product is manufactured in a social responsible way. So the Cradle to Cradle vision is really a world where products are designed following these principles. And then by using this product standard as a guide, our aim is really to encourage and challenge manufacturers and industry to embrace these ideals as part of their company design philosophy. So as a result, you'll find that our goal is really to develop products and manufacturing processes for those products that don't impact humans and environmental health. And if they meet the true ideals of a cradle-to-cradle product, which is a platinum level product, is the highest standard, you'll even find that the development of these products and processes are actually beneficial to humans and the environment. So hopefully, if you have not heard of Cradle to Cradle, but you will understand that the main tenet of Cradle to Cradle is about designing for perpetual reuse of these materials by emulating natural cycles. So it's not a cradle to grave mentality, it's a cradle to cradle mentality. So in an ideal cradle to cradle world, materials are designed to be nutrients in either the biological cycle or the technological cycle. These are terms that we use in our standard and in the program. So for example, in a biological cycle, the nutrients are non-toxic and biodegradable. Examples of these types of products would be a non-toxic shampoo or other personal care products. Nutrients in the technical cycle are materials that can be separated and recycled or upcycled after each use. So an example of a product in the technical cycle would be an office chair or a carpet tile. So the central goal is to retain or increase the value of these materials as they are reused in each of these cycles. And we only strive to reuse materials that are safe, and in other words, materials that do not contain hazardous chemicals. So I thought it would be helpful to first review a brief history of the Cradle to Cradle certification program. Hopefully you've heard of or maybe even read the book Cradle to Cradle, Remaking the Way We Make Things. This was authored by William McDonough and Michael Braungart and was published in 2002. I highly recommend it. You'll never, if you're like me, you'll never look at a material and a product the same way again after reading this book. But the book provides examples of cradle to cradle design in practice as a result of Bill and Michael working with companies over the previous 10 years to design their products according to the cradle to cradle principles. And as a result, it inspired a lot of companies additional companies to design their products and adopt the cradle to cradle principles. And a result of wanting to reward those companies and for achievement in cradle to cradle design, the company McDonough Braungart Design Chemistry, which is Bill and Michael's consulting firm in Virginia, started the certification program in 2005. So it was not meant to be an equal label, but it was criticized at the time for not being a third-party program with an independent verification system. So as a way to realize the potential of Cradle to Cradle and increase the adoption of these principles, Bill and Michael founded the Institute, Cradle to Cradle Products Innovation Institute, in 2010. So we are a nonprofit. We have our headquarters in San Francisco, and we also have offices in Europe. And the mission of the Institute is what you see here, is to bring about a global transformation by turning the making of things into a positive force for people, economy, and planet. And MBDC gifted the program to the Institute and as a way to make the program independent and a third-party verification system. So it took about 2 years to get the infrastructure in place and funding in place, and 2012 was a big year for us. The Certification Standards Board was created, which is the stakeholder board that now governs and oversees revisions to the product standard. We also started training other companies to work with manufacturers to assess their products for certification. And the version 3 of the standard, which is what I'll talk about today, was launched 1 year ago in January 2013. So to highlight the role of the Institute is, as I said, we administer the products program and oversee development of the standard. And that's our role as the scheme owner in the program. But we also serve as the certification body. As part of the scheme owner, we train and accredit other assessment bodies, as I mentioned, to evaluate products. And then as a certification body, we audit the assessment summary reports that we receive from those assessment bodies and issue the certifications. And then we also license use of the certification marks. So the product standard has 5 categories, and these are all based on the cradle-to-cradle design principles that I just discussed and described. So first is material health and material reuse. So these are tightly coupled. This is the selection of safe materials and also selecting materials that can be reused in systems and take-back programs and other nutrient strategies. So we're really focused on the design for continuous reuse of materials in each of these technological or biological cycles. And then relating to the manufacturing process, we want to power with abundant clean energy, so manufacturing products using renewable energy and keeping carbon out of the atmosphere. The fourth category is water stewardship. So this is about protecting water as a precious resource and manufacturing products in a way that do not impact local water quality. And then the fifth category is social fairness, and this is about manufacturing products in a way that is socially responsible. Okay, so the standard framework is essentially designed to engage manufacturers at 3 different stages, and we call these inventory, assessment, and optimization. So the goal is complete optimization of your product. So at the inventory stage, manufacturers are really just beginning to get a basic understanding of where they stand in each category. So for example, if you're just entering the process at a material health level, you're just identifying the generic materials in a product. So you're not getting to the point where you may be able to identify the CAS numbers, for example. And this is designed for companies that really are just starting, as I mentioned, and do not yet have the or not put the effort in to understand their supply chain. The material reuse at the basic level is just starting the process of identifying each of the materials in your product and determining which cycle they're appropriate for, the biological or the technical nutrient cycle. And so the manufacturing categories are similar in that you're just establishing your baseline. For example, in energy, you're quantifying the amount of energy and electricity that you're using and your direct on-site emissions. So as you move up levels in certification, you get to the assessment phase where you're beginning to compare where you stand now to where you want to be, and you're identifying opportunities to improve. And then as you begin your optimization journey, you're creating plans, you're creating strategies, and the infrastructure that's needed to optimize that product to reach the cradle-to-cradle ideals over time. So minimizing the negative impacts and then working to optimize the positive impacts over time. So at its core, also, the program is designed to recognize that manufacturers will be at different stages of that optimization. So the certification is awarded at 5 different levels: basic, bronze, silver, gold, and platinum. Basic is where the manufacturers would enter at that inventory stage. In version 3, basic is a provisional certification only. That means a manufacturer can only be certified for 1 2-year cycle. If they do not meet the requirements of the bronze level after that cycle is completed, then they'll be delisted from the program. But when we award certification at the basic level, that is, we are rewarding a commitment to improve your product and be part of this journey over time. So then, as you'd imagine, the requirements get more difficult as you move up in bronze, silver, and gold, and you must show progress at each recertification until you reach the goal, which is the ideal product, and that's a platinum product. So you can see that when I say that this is a sustainability platform, is the way we're requiring that progress is made on the optimization plans of the product in order to stay in the program. So this slide shows an example scorecard that a product would receive. We identify an achievement level for each of the 5 individual categories in the standard, and then the overall certification level, so in this case bronze, is equal to the lowest level achieved in each of the individual categories. So even though in this case a company may have made a lot of progress on developing their infrastructure for their material reutilization strategy, if they're only bronze, they've met the requirements for bronze and energy, so the overall product meets the bronze level. So this slide shows you some of the companies that have served as leaders in cradle-to-cradle design. They all have certified products and have adopted the cradle-to-cradle philosophy. Currently, we have about 300 certifications of products or product groups, and these represent several thousand products when you include all their product variations. We have about 130 companies currently from all over the world engaged in the program, and that number is climbing every day. We've seen an increase, particularly in the last year or so. And 60% of these products are currently in the built environment sector. Okay, so the standard applies to all industry sectors except food, beverage, and pharmaceuticals. And when we talk about a product standard, this also includes materials, subassemblies, and finished products. So for context. Okay, so now I'm going to go through each of the categories broadly to describe the requirements that need to be met in each category. And I will be focusing on version 3 of the standard. So if you're familiar with the program, version 2, the ban list only included PVC and its related compounds. So the ban list was expanded quite a bit for version 3. The ban list chemicals that you see here are very common to other chemicals of concern lists that you'd see. Our ban lists apply to all products and certification levels. So you cannot have any of these compounds present in each material, and these apply to intentional inputs greater than 1,000 part per million. And so unique to Cradle, we actually have 2 ban lists. We have one for the biological nutrient cycle and one for materials that are in the technological nutrient cycle. And that's to allow for a few of the ones that have asterisks here, such as lead, Teflon, and PAHs in managed technical cycles where no exposure is likely to occur. Okay, so given the importance of the Safer Chemical Challenge Program and attention to identifying alternatives, I wanted to provide you with some well, it's really a general overview, but a little more technical in how Cradle to Cradle conducts its material assessments. So for each material, what we term materials that are subject to review, each material receives a final ABCX assessment score. So materials subject to review are all materials in a product that are 1,000 part per million or higher in that product. So without going into too much detail here, the goal is to develop and eliminate product or materials that receive a capital X here that have been deemed highly problematic properties and must be phased out. So the goal, though, is to have those green or yellow ABC rated materials. So the first step in the process is to derive single chemical risk ratings for each chemical that's in those materials. And so the chemicals that are subject to review are those chemicals that are present at 1,000 part per million or higher in the material. So we start out by identifying the hazard flag which is a red, yellow, or a green flag for each of 24 endpoints for that chemical. And then as part of the exposure assessment, each hazard endpoint is considered in terms of whether or not exposure is plausible. So as a result of the comparison of those two, a risk flag is assigned for each hazard endpoint, and it's given a green, yellow, gray, or red rating, as you see there. So I want to point out that our exposure assessment process is not your traditional exposure assessment. There's no attempt made to quantify the exposure. It's a qualitative process. So asking the question, is there a plausible route of exposure? If there is, then the risk flag is equal to the hazard flag. If there is no plausible route of exposure, there's potential for that red risk flag to change to a yellow risk flag. And I'm happy to go over the details if anybody has further questions on that. So then taking all those individual hazard or the risk flags for each of the 24 hazard endpoints, those are subsumed into what we call a single chemical risk rating. So as you can see, here's an example. Each of the risk flags for all 24 endpoints are subsumed into the single chemical risk rating. So the lowest score of each individual risk flag is what equals the single chemical risk rating. So in other words, one red risk flag will result in a single chemical risk rating of X for that chemical. So taking that a step further, if you have a carcinogen in your material, and all of the others have received green or yellow, that red risk rating for the carcinogen is still going to get transferred into a single chemical risk rating. If there are any gray areas where insufficient data is able to be collected, that'll result in a gray single chemical risk rating. And then the difference between an A and a B single chemical risk rating is no risks for B and no hazards for the A level. So then each of the risk assessments for each of the individual chemicals in that material are combined, and the lowest of those equals the overall risk assessment for that material. And so then unique to Cradle, the last step is to compare the overall risk assessment for that material to what we call the cyclability of the material. So as you can see there on the right, there are definitions as to what makes the material, if it's rapidly degradable or recyclable or only slowly or partially, or not degradable or not recyclable at all. The lowest of those two scores are compared, and that is equal to the final ABCX assessment for that material that I described. So that was a very broad overview. We have documents on our website that can provide any answers that you might have regarding the details of that. Okay, so just to summarize the material health portion of the standard. So as you can see here, we start with no ban list chemicals. It applies to all certification levels. And then as you increase in levels, you're increasing the percentage of the materials that have been assessed in the product. You're developing optimization strategies for eliminating those excess materials. When you get to the silver level, you have, in addition to being at least 95% assessed, there's no CMR chemicals in a form that can result in exposure. And then getting to the gold level, which is where we strive to be, 100% of those materials are assessed by weight, and your formulation is optimized. So in other words, you have 100% positive chemistry and no excess materials. And then taking it a step further, for the platinum level, process chemicals have been assessed and also optimized. So no excess material chemicals that are used for the process. Okay, so an example that we like to show is that's putting these principles into practice and integrated the cradle-to-cradle framework into their chemical and material selection processes, Construction Specialties. They're a commercial supplier of wall protection and coverings, doors, floor coverings, etc. And they have put quite a bit of effort in R&D, innovative R&D, into developing an alternative for PVC. So that was their first challenge, and since then they've adopted these principles and now have an alternative that has no PBT chemicals, bisphenol A, or halogenated flame retardants. And so they have several chemicals that are cradle-to-cradle certified. In this particular one, they've reached gold in material health. And so that means obviously that they've received gold in all the other categories as well. And so Construction Specialties has noticed an economic benefit of adopting these principles, and have said that cradle-to-cradle certified products represent approximately 75% of their interior division's revenue. So that's exciting. Okay, so moving on to the reuse strategy again, we're talking about designing for reuse. A central tenet of this category is calculation of what we call the material reutilization score. And so this takes into account both the cyclability of the material, which is the left side of the equation, and then also the percent of the product that contains recycled content or rapidly renewable content. So in a cradle-to-cradle fashion, we actually consider cyclability, or so that's the extent to which it's recyclable or compostable. We count that value twice as high as the percentage of recycled or rapidly renewable content in the product. So here's an example of how that might be calculated for a product that has components that are 80% recyclable, but 40% recycled content. And so in this case, the score is 67, and this product would receive gold in material reutilization. So this summarizes the reuse category requirements. At the basic level, again, as I mentioned, you're just learning about your materials and identifying the appropriate cycle for those materials. You're beginning to develop a plan for how you're going to recover or reuse those materials. And then as your reuse score increases, your certification level also increases. At the gold level, you've completed a nutrient management strategy, and then the ideal is at a platinum level where that product is actively being recovered and cycled in one of the cycles. So a great example of a technical nutrient management strategy in action is Shaw Floors. Um, they have completely integrated cradle-to-cradle thinking into all of their operations, and they have reported that more than 60% of their $4.5 billion annual sales come from cradle-to-cradle certified products. So they've developed a post-consumer carpet recycling system where they're able to collect carpets of any type as long as they are made with nylon 6 fiber. They can reuse these carpet tiles to make more carpet. They have a particular product called EcoWorks where they will collect these carpet tiles for free, and it's a really great system where you just pick up the back of the carpet tile, and there's on the back is a 1-800 number that you call Shaw, and they will come pick up your carpet. So using this system, they've reclaimed about 100 million pounds of carpet each year that they can keep out of landfills. So it's a way to keep more valuable material in a continuous cycle of reuse. And so this shows the technical nutrient cycle utilized by Shaw. First, after the carpet tile is collected, they bring it back to their facilities where they can recover it and separate it. They separate the nylon from the other raw material components in the backing. Then they can mechanically break down the backing so it can be reused to make more backing. On the chemical recycling side, they can convert nylon back into virgin quality caprolactam, which is the chemical building block used to produce new nylon 6. So this is a great example of an innovative strategy for reuse that's also had economic benefits in addition to reducing their use of hazardous chemicals over time. So an example of a product that is in the biological nutrient management category is a company called DesignTex based in Switzerland. They produce products that are designed to enter the biocycle at their end of use. So prior to joining or adopting Cradle to Cradle, they had an issue with the toxic chemicals that were used to treat their fibers. And in fact, their scraps were considered hazardous waste and were subject to disposal regulations in Europe. But after the result of many years of assessment and to determine which chemicals would be safe from a cradle-to-cradle perspective, they've now developed a design process using rapidly renewable fibers made from wool and a natural plant fiber. So here's the example of the design for the biocycle. To do this, they narrowed a list of, I think it was 8,000 chemicals that were commonly used in textile manufacturing down to about 16 that matched the cradle-to-cradle material health criteria. And so a great story that goes along with this is you can see the ripple effect of cradle-to-cradle design. So in this case, Steelcase was looking for a new fabric for one of their cradle-to-cradle chairs, and they partnered with DesignTex as a result of their technology. DesignTex partnered with chemical companies to find chemicals that met their goals. And then DesignTex shared this chemical knowledge with other manufacturers so they could take advantage of it. And DesignTex also partnered with local mills to process and manufacture these new fibers. So you can see there are many positive outcomes from one innovative product design process. Okay, so moving on to renewable energy. At the basic level, the company is just quantifying and establishing their baseline of energy use and direct on-site emissions. And then as you increase in certification level, you begin to renewably source that energy and begin to offset emissions. So at the bronze level, you're covering 5% of the product's electricity and emissions, and then it jumps to 50% at the gold level. And for the platinum level, we are requiring that at least 100% of the electricity is renewably sourced or offset. And then at the platinum level, we begin to address the embodied energy of the product. Okay, so moving on to water. At the basic level, you're just beginning to look at issues surrounding water quality at the manufacturing facilities, so making sure there are no discharge violations, characterizing local water and business water issues, taking steps to identify the program or the problems. A facility water audit is completed as you move up, and then chemical companies that produce effluent have to begin to characterize and assess the process chemicals in that effluent. If no effluent is produced, then we ask the companies to address issues in their supply chain. As you move up, slowly we begin to optimize the process chemicals, and then the cradle ideal at the platinum level is that that water leaving the manufacturing facility is actually drinking water quality. It meets drinking water quality standards, which is a very high bar. Okay, lastly, in the social fairness category, at the basic levels, we're just asking companies to begin to look at do a self-audit and look at the potential impacts they have as a result of their manufacturing facilities being located in different regions. As you move up at the bronze level, this audit becomes more in-depth, and at the silver and gold levels, you are selecting requirements that either that 25% of the materials in the product have material-specific audits or certification. You're investigating supply chain issues and developing innovative social projects that are part of an integrated company policy. And then finally, at the platinum level, we require that a third-party facility level audit is complete. So this is, for example, a B Corp, or in Europe, the program that's commonly used is called SA 8000. Okay, and so lastly, I wanted just to summarize for you what it means and recapping what it means to be certified at each of these levels. So as I mentioned, beginning with the basic level, this is when products and the manufacturers are just starting out on the path to certification. So we're talking here as about you're just establishing the basic inventory of the materials, the energy use, the water use, and the social issues. Regarding material health, the product's materials are characterized. So for example, knowing the generic material types, but you may not know all the individual ingredients quite yet, and the assessment process has not yet begun. Regarding material reuse, you're beginning to identify the appropriate, what we call the metabolism of the product and its components, so that's technological or biological cycle, and really establishing a commitment, as I mentioned, to ongoing assessment and optimization. And this again is a provisional certification, and as part of that, companies may not use the basic certification mark on the product, but they can be used in marketing materials. So it's really at the basic level about getting on the path. So moving up to the bronze level, we consider you in the game. So a majority of the product has been assessed at this point, and that's including identification of its chemical ingredients. You've developed optimization plans for it to get rid of any of those excess materials. You're creating a strategy for how to address the electricity using renewable energy and how you plan to offset any emissions that might be generated, getting a better understanding of water flows, and then completing a full self-audit in the social fairness category. So getting more towards what we really want in products is at the silver level, where a product is at least 95% assessed by weight, and no problematic substances are identified in those 95%. X substances may still be present, but none are CMR chemicals in a form that may result in exposure. Optimization of the problematic substances is underway, and companies are actively working towards eliminating those. And at the silver level, companies have already begun to introduce renewable energy and carbon offsets, and then are working towards expanding water stewardship and social fairness through the supply chain. Okay, so gold level is what we want. Gold level products and materials are what we strive for. So at this point, a product is fully assessed and does not contain any excess substances. At least 50% of the product is produced using renewable energy, and offsets have been purchased for direct on-site emissions. You're continuing to expand the scope of water and social issues to the supply chain and to the local community. And then lastly, at the platinum level, process chemicals. This is the ideal cradle-to-cradle product. Process chemicals and all chemicals in the product have been assessed, and none of these have been assessed as X. The product materials are actively returned to industry or nature, so these are part of an active take-back program or other reuse program that's in place. At least 100% of that electricity and emissions are renewably sourced or offset. All water leaving the facility meets drinking water quality standards, and the company actively conducts an innovative project that positively impacts employees' lives, the community, or the product supply chain. So I hope that as a consumer or a specifier that this helps you understand what has been achieved when you see the different certification marks. For manufacturers, I hope this helps you understand the value of certification. We think by following and adopting this platform that it helps you stay ahead of regulations because you've adopted this platform in advance and are working towards eliminating any chemicals that might be hazardous in your materials. And I mean, so certification also shows your customers that you've adopted a cradle-to-cradle design process and the sustainability platform, and that you're on the path to continuously improving your product to meet that cradle-to-cradle ideal. Okay, so lastly, I wanted to show you an example, or our recently updated certified products registry. So if you ever have questions about which products are certified, please go to our website, which I'll provide for you in the next slide. We've recently increased the search functionality and speed, among other things, in the registry. So you, on the left-hand side there, you can see the search bar. You can search by industry sector. You can search by certification level. You can search by version of the standard that each is certified against. And then more recently, you can now search by LEED credits. So if you're not yet familiar, Cradle to Cradle has been recognized as a pathway for achieving LEED credit in version 4 of the standard in the material ingredient disclosure and material ingredient optimization options. So we hope that is useful to everyone. Okay, so that was a very quick overview with a lot of information, but I hope you're able to understand the value of the program. You can find all of our standard documents available for download on our website, and I encourage you to take a look at those on our website and check out those if you're interested. We've also released a book and also a PDF that includes a series of innovation stories from each of our companies, and so that'll give you an idea of what companies have gotten out of by adopting the cradle-to-cradle mentality and design processes in their selection process. So to learn more about Cradle, please just let me know and help make this vision a reality. Thanks. I'll take any questions.
Hi, everyone. This is Kim Richards with the National Pollution Prevention Roundtable. And first of all, I want to thank everyone for joining us for our first Safer Chemistry Challenge program webinar of 2014. Also, thanks to Susan for a fantastic presentation. I do want to let everyone know that the presentation and recording will be available on our website, p2.org, in the next week or so. Thankfully, we do have some time for questions, so continue to submit any questions that you have on your webinar control panel. Our first question, Susan, can you repeat really quickly what happens after 2 years if a company has not moved up to the next level?
Mm-hmm. They are, well, when they're basic, at the basic level, basic is a provisional certification. That's the only one that's provisional. So in version 3, this is different from version 2, but in version 3, basic can only be achieved once. So if they don't move up to the bronze level after that 2-year cycle has ended, they are delisted from the program. For the other certification levels, progress on their optimization strategies, at least in material health, must be made.
Okay, great. Thank you. Another question. Oh, you have more?
I was just going to add to that an example of making progress would be eliminating an excess material from the product or showing significant effort towards R&D and eliminating that material from the product.
Great, thank you. Another question. Is the exposure assessment done for all life stages of a product?
That's a good question. So as part of the assessment process, the assessors identify what we call product use scenarios. So those are scenarios during manufacturing, use of the product, and reuse of the product. So that's the scope of the exposure assessment.
Okay, great. Let me scroll up to the other question. Can you please describe the similarities and differences between the hazard assessment protocol and the green screen hazard assessment methodology?
That's a great question. We, as part of a project that we conducted last year, we took a first step toward with both programs and working with Green Screen to identify how the hazard assessment programs are similar and how they're different. So as you know, probably know, Green Screen is strictly a chemical hazard assessment tool, whereas Cradle to Cradle is built on that same core, but adds the exposure assessment piece and the cyclability assessment piece as part of our materials assessment process. And so as part of that effort, we found that we're actually collecting much of the same information from a data standpoint. And so, but where we diverge is that we currently, where we have the red, yellow, green system, Green Screen classifies those hazards differently. So they have 4 to 5 different hazard classification levels. So low, moderate, high, or sometimes also a very low and a very high. Um, the Institute is interested in working with Green Screen to explore further alignment and how we can get these programs to communicate hazard in a similar way. So we're in discussions there. So to summarize, I would say that we're mostly collecting the same information. There are some differences, but the differences are slightly in how we categorize those hazards.
Great, thank you. Next question. What databases or sources are used as standards for hazard endpoint?
There's some that are identified in the standard documents, but those are up to the individual assessment bodies to choose from. So they would turn to your typical authoritative list, but then also we expect them to review all of the scientific literature that they deem is appropriate for making those assessments. So at this time, we do not dictate exactly which lists to use because we expect them to determine based on their professional judgment which are the most important data sources to use.
Okay, thank you. Another question. A frequent critique of Cradle to Cradle is that some alternatives to banned materials, such as PVC, can have a higher environmental impact. For example, some bio-based products may have a higher LCI due to raising, harvesting, processing of the product base. How is the trade-off between environmental and health impact considered in Cradle to Cradle?
Trade-off between environmental and health impact. Well, I mean, each of the materials is going to go through that material assessment process that I described. So if what information is available for those hazard endpoints needs to be addressed. If there is if there's not enough toxicity data, that would be identified as a gray area, and then I would draw your attention to the guidance document that we have on our website that describes what how the risk flags are derived in those situations. Um, I'm not quite sure how to answer that other than to say that all of those chemicals and materials would go through the same assessment process. So if there is a hazard identified, I mean, PVC is on our ban list, but those chemicals that are proposed to be used would also go through that same assessment processes, and the hazards would be identified as part of that process.
Okay, thank you. Next question. For the cyclability criteria, how do you account for the fact that large-scale composting is not available in most areas? In other words, the product may be compostable, but no commercial composting is actually available.
Mm-hmm. So we don't actually do the assessment, so I don't have a clear answer on that. I would have to check with some of our technical staff, more technical staff, but I can tell you that there are definitions in the standard as to what defines degrade or compostability and biodegradability and recycling in the standard. I'm happy to, whoever asked the question, I'm happy to identify that offline once I find more information.
Okay, thank you for being willing to do that. Next question. Are certificates associated on a product basis, i.e. for each product, or to a company and its management system?
Are certificates based on a, can you repeat
So
the
yeah,
question,
so
please?
are there certificates associated on a certain product or to the actual company itself in the management system?
Oh, definitely to the product. Um, each product is or product group is assessed for certification. We do not certify companies or
Okay.
processes or anything. It's strictly a product certification program.
Okay, thank you. Next question. Can you explain why in the water category there's no meaningful change required until the gold level? Even simple water conservation is easily done by most organizations, even in office environments.
So from the cradle to cradle stamp, I mean, it depends what you're saying is meaningful. Um, I mean, I think there's more benefits that can be gleaned rather than just reducing water use. While, I mean, reducing water use certainly is a good management and efficiency tool, but the standard itself does not reward my company for using less water. The idea is it's focused on making the water that is used safe. So eliminating, we stress more importantly, eliminating the chemicals that are added to that water rather than limiting the amount of water that itself is used to make the product.
Okay, that makes sense. Next question. Can you explain what you think are the top 2 or 3 reasons why there are no products that have the platinum certification? What are organizations finding most challenging in regard to this?
That's a great question. And the answer is because it's really hard to be platinum. The I mean, it's a rigorous program. So meeting the platinum level requirements, I'd say the biggest. Well, I think it depends on the company. So from what I've heard, energy. It depends on the sector, of course, but there are a lot of energy intensive processes. So being able to find a local renewable source of energy or being able to afford offsetting that is a challenge for many companies. Uh, the other big one is just material health, really, is I've been told that the assessment bodies that are working with the supply chain in many cases have a very difficult time getting suppliers to provide all of the information on the ingredients. And so that's why you'll find that a company only has 75% or 95% of their product assessed, and that's because of the limitations that they have in getting that information. So I'd say those are the two biggest. And then also meeting the platinum level, you have to be able to not have any excess chemicals. So in many circumstances or situations, those chemicals just aren't available, or those materials just aren't available um, to the company. So really eliminating every single excess chemical is challenging depending on the product.
Okay, great. That was some a good explanation there. Next question. Are Cradle to Cradle's chemicals restrictions in line with the European directives such as REACH, or do they go beyond that?
So I think the question is, how does our ban list compare to the REACH substances of very high concern list?
Yes.
I don't know the details of that offhand, but from what I remember looking at the list, there's a lot of similarities. Uh, yeah, I mean, sorry, I don't know the content of that list offhand, but our
Okay.
ban list, as you can see, contains a lot of the most, I would say, of the main chemicals of concern that have been identified.
Okay. On to the next question. Can you expand on the exposure aspect? Would forms that may result in exposure consider the unexpected, like flame retardants and dust?
hmm Okay, so maybe it would help for me to go back to that slide. So it, I guess I would need a specific question, but the hazard ratings are assigned. So for we have one, we evaluate 24 different hazard endpoints in the product, or for each chemical, and each of those hazard endpoints is considered in terms of whether or not there will be exposure in those product use scenarios that are identified. So for example, and it's like I said, it's not a quantitative assessment. This is a qualitative assessment. So if exposure is plausible, which in most cases, yes, then the resulting risk assessment flag will be equal to its hazard flag. So in other words, exposure is not a factor if it's plausible. So some examples of where that risk hazard flag or can be overturned per se is lead and cast aluminum. Lead and cast aluminum cannot migrate out of that material. So in that case, though lead is a neurotoxin, it has a red hazard flag for that. the risk flag would change to yellow because there's no plausible route of exposure of that lead outside of that cast aluminum material. So I can say that in the majority of cases, because exposure is plausible, that the risk flag is equal to the hazard flag. So I
Great.
hope that answers the question more. And this is explained in more detail in the guidance document for the material health assessment methodology that's on our website.
Great, thank you. Can you provide any information on the range of pricing and certification costs from basic to platinum, kind of in annual numbers? Is that something
Hmm.
that you have
Well,
any
it
idea of?
doesn't. Sure. I would say it doesn't really, the certification level is not a factor in that. It's really about how far along the sustainability pathway that a certain manufacturer may be already. So, well, first of all, the Institute, the charge for certification is to review the audit reports, and that's a trivial amount compared to what is actually the cost that may go into the company's efforts or working with an assessment body to get their product evaluated. So I, from what we're not familiar with the costs charged by our assessment bodies, but I would generally say it depends on the complexity of the product and how difficult it is to get information from the suppliers. And so I'm told I think that can range from about $7,000 or $8,000 up into the tens of thousands, so maybe $50,000 or $60,000, and that's just to work to get the product assessed. But again, it really depends on how far along the company already is and what level of input is needed to give to the assessor. So, for example, if it's a simple product and a company is very well familiar with its product's ingredients, that cost would be much lower. If the assessors have to work with the supply chain, that are 10 suppliers deep, a substantial more amount of effort needs to be put into gathering all of that information. So
Okay.
hopefully that answered the question.
Yes, thank you for expanding on that. Really quickly, is one of the certified products from the United States Postal Service? Do you know that offhand? I think someone seems to have seen that in your slide. Just want to make sure that's true before
Mm-hmm.
moving on. Okay. Then they were asking, can you explain some of the involvement by the USPS and what was involved in their certification?
I'm not familiar with any of those details. All I can tell you is that they had some of their mailers, the cardboard mailers, certified. I'm happy to get back to the person that has that question, but I'm not familiar with their involvement. It's the assessors, our assessment bodies that work with the individual companies. We receive the results of those assessments and audit those.
Okay, great. Next question. Is a certified cradle to cradle product truly cradle to cradle if the consumer then proceeds to throw the product in the trash rather than in the recycle bin after using it?
Mm-hmm. Well, I mean, ideally I mean, of course, it's not going to be in the proper reuse cycle, of course, but the idea is that the infrastructure is developed so that we can make that or get that product in its proper cycle. So, I mean, if it's a compostable product, hopefully that's getting it into the right cycle. It's certainly not ideal. But the goal is what we really need to do is to develop the infrastructure and the human behavior habits to make sure that those products do get in the cycle. So our goal is to outline a strategy for how to get there and a standard so that we can get more people on board to design products following the strategy and get the infrastructure in place so that that doesn't happen.
Right, right, that makes sense. Next question. How frequently are these products reassessed?
So in version 3, the certification is for 2 years. So a company must update their information and demonstrate that progress and go through the recertification process every 2 years. With version 2, it was 1 year.
Okay, great. Thank you.
But also, I should mention, but during that time, from what I'm hearing is that, I mean, this is, again, it's not just a pass-fail program, so it requires an ongoing relationship between the manufacturer and the company to work over time to make progress on that optimization path. So yes, there's effort in the form of paperwork every 2 years, but in between there, the expectation is that that company is working to address the issues identified in their optimization strategies.
Okay, thank you. I have an example leading into a question. So, for example, a product receives basic level of certification with 999 parts per million formaldehyde. At gold level, how much formaldehyde could be in the product?
I mean, I'd have to know more about the product. Not sure how to answer that question. I mean, if it's 999 parts per million, then, well, first of all, formaldehyde actually is not on our banned list. So I'm not sure what the question is.
Okay. I think it was just kind of like, so is there's not really a certain level that it has to decrease for each chemical before it moves on to the gold level. It just kind of depends.
Well, you mean, so it's not about reducing the concentration of the harmful chemical in the material. It's about reducing the material in that chemical from the product altogether.
Mm-hmm.
So sorry, I'm not really sure what the question is.
Okay. Well, maybe we'll get a clarification at some point. The last question is, do you see that there are common classes of chemicals that do not have X chemicals? If so, what are they? Sorry, actually, and yeah, sorry, and I'm actually not sure of the question actually either as I'm reading it. So, yeah, again, I'm unsure.
Well, so I guess the question is, are there what classes of chemicals would not receive an X rating in our process?
Right. Yeah.
I mean, there are a whole slew of circumstances surrounding that. Sorry, I don't have a good answer. I mean, I would expect that more naturally bio-based materials would suit this. Staying away from organohalogens. Organohalogens is an endpoint. In the non-traditional sense, it's not an endpoint, or in the traditional sense, it's not an endpoint. But in our standard, and a material or a chemical can receive an X risk assessment rating just by being an organohalogen that's present above 100 part per million in that material. So generally steering away from those.
Okay, great. And that is actually the end of our questions. So I'm going to throw it back to Cindy to just kind of finish up our webinar for today.
Great. And Kim, if you could put up that last slide. There we go. Great. That was a really excellent presentation by Susan Klosterhaus from Cradle to Cradle Product Innovation Institute. And we thank her as well as all the attendees who've taken the time to join us today. We want to remind you to please complete the survey that you'll receive following the webinar to help us out with improving our webinars. I wanted to let you know about a few upcoming events. We have an entire webinar series here for the spring that goes through May that you'll receive a notice on. But our next one is March 18th at 2 Eastern on EPA's Safer Chemical Ingredient List. And then we have a Great Lakes Green Chemistry Conference coming up in Cleveland, which will be April 1 through 2. And it will be bookmarked by a couple of meetings, the Great Lakes Regional Pollution Prevention Roundtable meeting on the 31st and a green screen workshop training on April 3rd. So pretty much a 3.5-day event there. And then June 4th will be another green screen training workshop in Buffalo, New York. So we've been hoping to capture folks in the far eastern end of the Great Lakes region. So we're pleased to offer that one. We hope you'll check out our website at p2.org/challenge and become a member of this Safer Chemistry Challenge program to help advance some of your green chemistry efforts and have access to the resources. You can join that program at no cost through June of 2014. And finally, do contact us with any questions at saferchemistry@gmail.com. And again, we thank you for joining. Have a great upcoming weekend.